I prefer to bring up the environment dynamically and tear down the environment when they are not required. To do this dynamically, I picked up OVS, an open source implementation of virtual switch, CI/CD tool Jenkins, shell scripts, Ansible, Terraform, Packer, and Groovy that comes with Jenkins. I built containers using Docker and I brought up virtual machines based on Ubuntu operating system. Scripts brought up Ubuntu virtual machines from ISO, Docker containers dynamically and configured overlay across all clouds. I picked up multiple parallel pipelines within Jenkins that helped me to build the infrastructure faster in parallel within multiple clouds. Building virtual machine from ISO takes most of the time as I didn't use the pre-built virtual machine template. vSphere takes less than 5 minutes with pre-built virtual machine template. In public cloud, script takes about 5 minutes to build the infrastructure. I have a bunch of environment variables in the script which really defines the backbone variables required in each environment. I added comments throughout the scripts where I can and you can also find information in Jenkins file, readme file. With the environment variables, you can choose overlays such as Genu or VXLAN. You can prefer to destroy the resources once you tested them. You can choose subnets and you can define cloud API key files that require to connect the cloud. You can either define them in the main Jenkins file or you can have it in the Jenkins GUI. You can find more details in the Jenkins file. When it comes to keys, I recommend you to use Vault or any form of encryption to store the API keys. In this project, I am using environment variables to store the keys as I didn't share the script with others during development phase. Keys won't be visible in the logs. If you switch on the debug, keys will be visible in the logs. Give more attention when you are publishing scripts in GitHub and when you are sharing the log files with your colleagues. In this pipeline, you can see 6 stages, all are in green. Green color always makes me happy. Let's look at the stages one by one. In the first stage, initializing variables as namestates, I am assigning values for the variables. If you want to assign values dynamically prior to creating resources, you can do in this stage. In the second stage, infrastructure changes, Terraform script is bringing up virtual machines in all environments. This stage also provisions the virtual machines with necessary packages. In the third stage, containers and VM config, Ansible scripts are bringing up containers in all router virtual machines. We are also gathering IP addresses to terminate tunnels in this stage. In the fourth stage, tunnel config, this is where all magic happens. Connectivity is established based on the information prepared in the previous step. Ansible scripts are bringing up tunnels between hub and spoke sites over router virtual machines. Initially, I thought of writing the tunnel configuration in Python. However, I managed to accommodate this in Groovy. In the final stage, testing, connectivity is tested from the client virtual machine located in the hub site to the all containers on client virtual machines located in all spoke sites. Once the testing is completed, scripted stage unconfig will be called from the main script to destroy the all resources created in previous stages. In some occasions, parallel pipeline try to access variables at the same time. To avoid overwriting, I defined lock blocks within parallel pipeline. It is similar to semaphore. Lock restricts you from accessing same variable concurrently multiple times. If a stage fails, you don't want to stop the whole build process. You can dynamically mark a stage as failure using unstable function. You can dynamically add or remove stages. As you see in this screenshot, I used only 3 clouds in this deployment. I grayed out unused clouds during build and removed all other clouds in the remaining stages. I came across an old school issue while testing the tunnel, looping issue within the tunnel. I tackled the looping issue by implementing a spanning tree solution. I came across some challenges while writing this script, especially when I try to bring up 2 interfaces in router virtual machines. I will cover the challenges I had with each environment in part 4 and part 5.